Look on that thing. Does it say record? Thank you. Okay. But you're going to be in charge of this from now on.
I don't know. I think
She's got it. Okay, that's fine. Okay, right. So before I forget, there's a little timetable clash just tomorrow. What's the matter?
Just disinfecting.
Oh, okay. There's a little timetable clash tomorrow when for half an hour I'm teaching matrics and I'm teaching you. And so you're going to go to Mrs. Florence's classroom. I've set work for you to do. You're going to be working with Miss Tanjaquayo. And at the end of that half an hour, you'll come back here. So she's just supervising you, and you're doing work that I've set for you. Just for that half an hour, then you'll come back. Okay? Right. Okay, so let's go. So yesterday, no, wrong thing. Okay, yesterday we were busy with the difference. So first of all, the importance of having coordination between various parts of an organism. If an organism is especially multicellular and has different parts specialized to perform specific functions, then it's important to have coordination between the working of the different parts. Okay? And I said to you that in a human body, that occurs in two different ways, the nervous system and the endocrine system. You will deal with the endocrine system in matric. It's one of the sections in matric. So it's easier if you understand it at this level, then next year you will find it easier to cope with. Do you want to sit closer to the heater and switch the heater on?
Okay.
Are you sure? Okay, I'm a little bit worried about the fact that you're shivering. Have to say. Are you sure you're okay?
Yes, I'm sure.
Okay. If you do get cold, just get up and move close to the heater, but check that it's on. I'm not sure that it's on. Okay. So we then started with the actual nervous system. And I said to you that the nervous system always works in exactly the same way. So there is a change in the environment which is perceived by a sense organ. And that change in the environment is called a stimulus. And a stimulus could be anything like a sound wave with me shouting at you, or it could be you walk into the kitchen and you smell some nice food cooking. Okay, so a stimulus can be a whole variety of things. It could be the temperature of the bath water when you put your foot in the bath. Okay, but all of those things are something in the environment that causes a response in what is called a receptor, and a receptor is a sense organ. Okay, so it would be a stimulus causes a change.
Oh, it's in the
It's the
science.
bloody sound spawn. Greatest joy in their life is to scare the hell out of me. I think they've got a bet going how soon it's going to take me to say the F word out now. Okay. All right. Perceived by a receptor. And a receptor, remember, is a sense organ. And there are lots of different sense organs. So you would... We always talk about how many senses? 5. In fact, there are more than that. So that would be sight, sound, touch, whatever, taste. And? Say again? Okay, can't think off the top of my head what the other one is. Okay, what are you doing? What are you doing? No, but you should have done that at the beginning. Okay, I'm counting 2. Get it out. Do what you need to do. Okay, remember guys, you do not have to take notes. I promise you, it's all in the notes, it's all in the PowerPoint. but it's up to you depending on your learning method as to whether you want to take notes or not. Okay. In fact, there are other senses as well. For example, Sam, don't look. In what position is your right foot?
What do you mean? Like,
So is it on the floor? Is it in the air? Is it against the leg of the chair or the leg of the table?
or my toes are against the leg of the table?
Okay, toes are in the leg of against the leg of the table, and her foot is in the air. So it's not flat on the ground. Okay, what has told her that her foot is in that position? And those are also sense organs, but they're not the normal traditional ones that you think of when you talk about an eye or an ear or a whatever. That kind of sense organ is called a proprioceptor or a proprioreceptor, and they are tiny little structures in the muscles and in the joints that send constant information to the brain, saying information about the position of the various parts of the body without you having to think about it. And they're terribly important because they work in terms of they constantly let the brain know. Okay, what did I press last time? And it's all that kind of information is used by the brain to enable the body to balance. So that you're not constantly going, my left foot is higher than my right foot, therefore I need to do whatever to be able to balance. All that information from the proprioceptors is constantly going to the brain, and it's being processed by the brain. So those receptors, whatever they are, send an impulse to the central nervous system. Now, this is one of the things that you're allowed to abbreviate in life sciences. And the rule goes in life sciences, you may not abbreviate unless it's an accepted scientific abbreviation. If you are going to use an accepted scientific abbreviation, like CNS for the central nervous system, then the first time you write it in a test or exam, you write the whole thing out, you put in brackets CNS, and after that, for that test or exam, you may write CNS. Okay, everybody happy with that? And remember that the CNS or central nervous system is the brain or spinal cord, and the importance of the brain or spinal cord is that right. So the brain or spinal cord processes the information that it's receiving from the receptors. So the brain or spinal cord would then, and I'm putting it in very simplistic terms, don't you dare do this in a test or exam, would then take that information, send it to the appropriate part of the brain, because different parts of the brain have different functions. That part of the brain would then take that information, process it, and make a decision as to what's the most appropriate response to that particular stimulus, and which part of the body should do that response. It then sends an impulse, again via a nerve, to what is called an effector organ, and the effector organ responds to whatever that initial stimulus was. So depending on the stimulus, an effector organ would respond. So if my eyes saw step, then the appropriate effector organ would be the leg muscles to pick my foot up higher to be able to not fall flat on my face on that step. Okay, right, all happy with that?
Yes.
Are you always like this?
No, ma'am.
You're going to tell me it's because you need food. So I'm not going to ask you why you're not always like this, why you're like this when you're not always like this. Okay, there are two parts to the nervous system in terms of structure and position. So first of all, let's deal with the purple part, which is the central nervous system. And the central nervous system consists of the brain and spinal cord. You are not going to call this thing a spine. Or you can. I'm just going to give you naught. Okay? Because remember that there are two parts to this structure going down the back. The first is the bones, and you're going to call that the vertebral column. And the second is the cord of nerve tissue that goes down the center, and you're going to call that the spinal cord. The trouble is when you guys use the word spine, you are not clear, and I'm not clear, whether you mean the bones or whether you mean the nerve tissue. And that word spine is used interchangeably for both bones and the nerve tissue, or both together. And so just don't use it. You're going to say a spinal cord, or you're going to say the vertebral column, depending on whether you mean the bones or whether you mean the nerve tissue. So if you're talking about the nerve tissue, you're going to talk about the spinal cord. Okay, is there an ancient cord in spinal cord?
No. Not this specific cord.
Say again?
Not this specific cord. The spinal cord, there's no H.
Which cord has an H?
Like musical chords.
Musical chords. Okay, so this is not a musical chord, and therefore there's no H in it. So I'm not circling 50 times with a pink pen your H's. Don't put H's. Okay, right, you happy with that? Okay. Then what is here drawn in orange is what is called the peripheral nervous system. And you're happy with this word peripheral? You know that it means around the outside of something. And the peripheral nervous system consists of the nerves. And there are two different kinds of nerves. So there are, in terms of structure and position and function, there are nerves that have neurons which transmit impulses from a receptor to the spinal cord or brain. And then there are nerves which transmit impulses from the spinal cord or brain to an effector. Okay? So there are neurons here, and there are neurons that function there. And those two have got different structures to each other. So these ones can only transmit impulses towards the central nervous system, and these ones can only transmit impulses away from the central nervous system. No one neuron can ever do both of those things. Okay. They can be bundled together in one big nerve. So it's possible to have a nerve which has got neurons transmitting impulses in that direction and neurons transmitting impulses in that direction. So it's just like a two-way street, but it's not possible for one of the neurons which transmits impulses that way, structurally that neuron can't transmit impulses that direction. Okay, you happy with that? Okay, all right. So, to summarize again, there is always, and the green part represents the peripheral nervous system, and the purple part represents the central nervous system. So, sense organs, common group word, receptors, are sensitive to stimuli in the environment, and they then respond by sending an impulse through a particular kind of neuron that we'll discuss just now towards the central nervous system. The central nervous system is also made of neurons. We'll talk about that. That then processes the information and sends impulses out through a different kind of neuron towards what is called an effector organ, and effector organs are always muscles or glands. So if the stimulus had been the sense of smell of nice food cooking in the kitchen, then the effector would have been a gland, because it would make the mouth produce more saliva. The salivary glands produce more saliva. It would make your mouth water. Okay? But if the stimulus was perceiving a step, then the effector organ would be the muscles of the leg telling you to pick your feet up higher. Okay, all right, happy with that? All right, okay, blah, blah. Okay, you learnt about neurons when you were in grade 10. So I'm presuming this is revision of grade 10 work. Were you all at this school in grade 10? For the whole of grade 10, Carla?
No,
Term 3. Okay,
we did
you did. Okay. All right. So remember that neurons, not to be confused with nephrons, just because they are both words that begin and end with an NS. Don't under pressure in a test or exam put the wrong one. Okay, because then you could lose a whole lot of marks if they follow on questions. If you put the wrong one, you could lose all of those marks. Okay, so neurons are the functional units of the nervous system. Remember you learned last year that they are very long, thin cells and they are able to transmit electrical impulses. So you learned last year that there are 3 parts to a neuron. The one important part is the most central part, and remember that that is the cell body. Okay, it's got a nucleus, it's got other things. Did you learn about neurofibrils and little granules? No. Okay, it's fine. You don't have to know about it. Alright, so there's cytoplasm and there's a nucleus, and that is the central part. Then transmitting impulses in towards that are extensions of the cytoplasm. Okay, and remember that those extensions of the cytoplasm are called, remember if your label line goes to 1, your label must be in the singular, sorry. So you're going to call it a dendrite. Okay, so each of those things is a dendrite. And the function of a dendrite is to transmit an impulse towards the cell body. So direction of impulse would always be towards the cell body in a dendrite. Okay? Alright, and then an axon leaving the cell body. Right, so these sticky out things are called processes. Are you okay with the word process in this context? Doesn't mean something that's happening, it means a sticky out part. Okay, right. Everyone happy with that? Okay, so that then would be an axon. Okay, and the axon divides into structures called either telodendria or terminal branches. And each terminal branch ends in a little swelling called a synaptic knob. Are you okay with that? Do you remember that, guys? Okay, but you'll learn it, hey? Alright, so dendrite, cell body, axon, terminal branch, synaptic knob. Then remember that the axon is insulated by means of Schwann cells, and Schwann cells are tiny little flat cells. Okay, so this could represent, for example, a Schwann cell. Okay, it's a little flat cell, and the Schwann cell, remember, wraps around the axon. And the Schwann cell gets bigger and bigger and bigger as the Schwann cell gets bigger and bigger and bigger as the neuron ages. Okay, so in an axon of a young neuron, the Schwann cell is not as big as this. Okay, And the Schwann cell, remember, wraps around the axon. So in a young neuron, the Schwann cell might only wrap once around the axon. And then as the neuron gets older, the Schwann cell gets bigger and bigger and bigger, and so it'll have more and more and more wraps. Okay, and then the final wrap, it doesn't matter how old this thing is, the final wrap has all the cytoplasm. You see how the final wrap got all the air? The final wrap would have all the cytoplasm. So before the final wrap, if I cut a cross section through this, what I'm going to see is, there's the axon in the middle. Okay, so that's the axon. And wrapped around it, would be layers and layers and layers of cell membrane. Here it was plastic, there it is cell membrane. And the very last wrap, and please don't call it a wrap, because it's not a wrap, but it's the last cycle going round. That very last one is going to have all the cytoplasm. Okay, you happy with that? Okay, and it's going to have the nucleus. Okay, so somewhere in that last one is going to be the nucleus. So these layers here form what is called the myelin sheath. And that's the layers and layers and layers of cell membrane. And this entire structure is called a Schwann cell, with a capital S because it's named after someone. So up until now, we haven't had any other proper nouns, and therefore none of the labels we've had up until now have had a capital letter. But Schwann cell is a proper noun, and therefore it's got to have a capital letter. So remember that there would be a number of Schwann cells depending on how long the axon is. So if I started here, I drew the first Schwann cell here. Okay. There would be layers and layers and layers of cell membrane, and that is myelin sheath. Okay. And this whole structure is a Schwann cell with a capital letter and two ends. And you may or may not see the nucleus of the Schwann cell in that cytoplasm at the end. Okay, so remember this is all the cytoplasm because it got pushed to the last roll. Okay, you happy? All right. Then there would be another Schwann cell with myelin sheath, blah, blah, thingamy-bob, and another one with myelin sheath, blah, blah, thingamy-bob. And there's a tiny little gap in between adjacent Schwann cells, and remember that that is called a node of capital R, Ranvier. Okay, a node of Ranvier. So this is a typical neuron, okay? But different neurons with different functions and different positions and different structures have got different structures. Okay, everybody happy with this? Do you remember this from last year? I've got two nods and one half-hearted wiggle of the head. Okay.
Some of this. Yeah, we didn't do it in this much detail.
Are you okay with the detail that I've done today? You sure? Okay. And so let's have a look at this. Okay. So this then shows the cell body, okay, with the nucleus in the cell body. Each of these little things, not the orangey things, each of these things is dendrite. They're leading into the cell body, and they would transmit impulses towards the cell body. Okay, then leading out of the cell body, this would continue down there. Okay? And here you can see it enlarged. Sorry. Okay, so this would be the axon going down the center here. Okay, and what you can see is there's one Schwann cell, and there's another Schwann cell, and then this would be another Schwann cell. And the areas between Schwann cells where there is no insulation around the axon is called a node of Ranvier. And a node of Ranvier is a proper noun, it's somebody's name, and therefore it's got to have a capital R. Okay. All right, the node of Ranvier is going to be terribly important. We're going to talk about that just now. Everybody 100% happy.
Mom, is it mode of Ranvier or node?
Node, sorry.
Thank you, Mom.
Okay. Right, so looking here at this typical neuron here, so this is exactly the same as that drawing, but sideways. So dendrites, cell body, axon is the funny pale green one, and then you can see Schwann cells wrapped around the axon, and between successive Schwann cells, the node of Ranvier. And then the very pale stuff is the myelin sheath. So the myelin sheath is simply that region where there are many layers of cell membrane because the Schwann cell is wrapped around and around and around the axon. Okay, and the function of the myelin sheath is to insulate. So in exactly the same way as an electrical cord is insulated by this layer of stuff around the outside, or else I would get a shock, so too does the myelin sheath insulate the electrical, it insulates the axon so that the electrical current going through the axon does not dissipate. In other words, it doesn't affect surrounding organs. It doesn't just disappear in all directions. So if there was an electrical current coming along here, the function of this insulation is to make sure that that electrical current gets all the way to the target where it needs to go to, and that it's not going to be lost along the way. Okay. There are certain neurons in the body that don't have a myelin sheath, or in certain organisms they don't have a myelin sheath. They are called unmyelinated neurons. And unmyelinated neurons, two things. The speed of impulse transmission is slow, and if they are injured, they don't heal as effectively. Okay, so somehow the Schwann cells increase the chance of a neuron healing if it is injured. Okay, you happy with that? You may have a 1-minute squirm break. Not long enough to go and get your food. Where's your food? Where's your food?
Reception.
So, Usain Bolt, how fast do you sprint?
We'll see, man. What's the time? How much are you timing, man?
Okay, go. 1 minute.
If you want to go to the bathroom, you have to go all the way around.
Yeah.
That is correct. I'll give you my Fitbit so you can get steps for me.
Can I go to the bathroom?
Run!
You have to run.
Yes. Leave your phone here.